Okay, so we're on problem 4 of practice exam 3, and in this problem we're given a power series and we want to determine the radius of convergence and the interval of convergence. So to start off, we'll first determine the radius of convergence. We'll do this by the ratio test, and before we even do that, what we'll notice is that this power series is centered at x equals -3, and the reason being is because we look for a term like x minus a to the power n in our power series, and then this tells us that the center of the power series is a, and in this case this x plus 3 is like an x minus a -3, and so then our center is at -3. Okay, so we know the center, and then once we know the radius, we'll have a pretty good idea of the interval of convergence, and then we'll just need to check the endpoints to be 100% sure about that. So like I said, we're going to look at the ratio test to determine the radius of convergence. So to do the ratio test, we look at the ratio of the n plus first term in the power series to the nth term in the power series. And so the n plus first term is just substituting n plus 1 everywhere you see an n in these terms. So it'll look like 2 to the power n plus 1 times x plus 3 to the power n plus 1 divided by the square root of n plus 1. And then the nth term was already written out for us, so it's 2 to the power n, x plus 3 to the power n divided by square root of n. All right, and so there are a lot of common factors here. So we have n plus 1 factors of 2 in the numerator. We have n factors of 2 in the denominator, so we can cancel n of those. We have n plus 1 factors of x plus 3, n factors of x plus 3, so we can cancel. And then the rest of the stuff will just carry along with us. So what we have at this point is there's still a 2 remaining in the numerator. There's an x plus 3, and we're not sure about the sign of that, so we'll keep absolute values around this. 2 is always positive, of course. So this is currently what I have. And then coming from the rest of the stuff, this is in the denominator of the denominator, so I can push it to the numerator. And then this is in the denominator of the numerator, so I can push it to the denominator. And then I can write it all under a common square root, so I have square root of n over n plus 1. Okay, and then we want to take the limit of this ratio as n goes to infinity, and clearly 2 and absolute value of x plus 3 have no dependence on n whatsoever, so this stuff will just remain exactly the same as we take our limit as n goes to infinity. This is the only thing that will change in the limit. So we need to take the limit of the ratio, so as n goes to infinity, I want the limit of an plus 1 over an, an absolute value, right? So this is 2 times x plus 3. I can just pull to the front because it has no dependence on n, right? So this is a constant with respect to n. And so then I just need to determine what the limit of square root of n divided by n plus 1 is as n goes to infinity. And the way that we're going to do it is we'll multiply the numerator by 1 over square root of n. We'll multiply the denominator by 1 over square root of n. And since I'm multiplying by 1 over square root of n, this will come into the square root as 1 over n. So what we're going to get, that remains the same. It was just out front of our limit to begin with, and the rest of the stuff now looks like limit as n goes to infinity of square root of, so I have n times 1 over n, so it'll just be 1, and then in the denominator it'll be 1 plus 1 over n, and then obviously as I take this limit as n goes to infinity, this just goes to 1. So my limit is equal to 2 times the absolute value of x plus 3. And then what the ratio test tells us is that if our limit, which is 2 times absolute value of x plus 3, if this is strictly less than 1, then we have absolute convergence, right? So then convergent And additionally, what it tells us is that if the limit in absolute value is greater than 1 strictly, then this is divergent. Okay, so this together tells us that the radius of convergence, well, it's going to come from this term, right? 2 times absolute value of x plus 3 is less than 1. So the way that we're going to get it, it'll be equal to 1/2. But basically that's going to come from the fact that when we divide by 2 in this expression, we'll get this x plus 3. This is our variable minus our center of the power series, right? In absolute value, this has to be less than a particular value, in this case 1/2, for it to be convergent. If it's greater than 1/2, of course, by this expression, then it will be divergent, and this determines our radius of convergence as 1/2. So we have that the radius of convergence is equal to 1/2. We know the center is -3, so essentially what we have at this point is that here we have -3, and then if we go to the left by 1/2, so this would be -3.5, or in other words, -7/2, right? We know that we at least have convergence up until this point. We're not sure about that actual value for x equals 7/2. We have to check that one. And also if we go to the right, 1/2 units, so this will be -5/2. Then we have convergence in this open interval at least, and we're just not sure about the endpoints, so we're going to have to check the endpoints now. So let's check x equals 7/2, and let's see what happens. So to check x equals 7/2, if it converges, I just want to substitute this value in for x in my power series. So I'll just write out everything exactly the way it is. And let's see, when I substitute -7/2 plus 3, right, what I'll get is this -7/2 plus 3. This is equal to -1/2. So this is the series from n equals 1 to infinity, 2 to the n divided by square root of n, and then I have -1/2 to the power n. And so you see I have a 2 to the power n. This is essentially just a negative 2 to the power minus n, but basically what I'm saying is this 2 to the n will cancel with this 1/2 to the n portion of this term. And so what this will be equal to is an alternating series starting at n equals 1 going to infinity. So we'll have a -1 to the n that sticks around because the -1 to the n didn't cancel out. Only the 2 to the n and the 1/2 to the n cancel. And so then we have something like this. But this is an alternating series. So we can show convergence of this alternating series by the alternating series test. Right, so we look at the two hypotheses of the alternating series test, make sure that this series satisfies those hypotheses. And essentially what that comes down to is we need to show that 1 over square root of n is decreasing and the limit as n goes to infinity is equal to 0. And both of these things are clearly true, but either way we'll show them. So we know that this is greater than if I make the denominator larger, right? That just makes it smaller. So this is our n plus first term. And then also the limit of 1 over square root of n as n goes to infinity is certainly equal to 0. So the alternating series test will tell us that this is indeed convergent. So it converges on the left endpoint, so we can include that one, put a check mark. And so now the only other question is, what about the other endpoint, -5/2? So we'll look at x equals -5/2 and see what happens. Right, so we just substitute that value for x into our series. So we have 2 to the n over square root of n times -5/2 plus 3 to the power n. And so -5/2 plus 3 is just positive 1/2 this time. So this series turns into 2 to the n times 1/2 to the n over square root of n. But I think it's pretty obvious that 2 to the n times 1/2 to the n, those are just going to cancel, right? We'll be left with a p-series. This is a p-series with p equal to 1/2. So n equals 1 to infinity, 1 over n to the power 1/2. This is a p-series with p equal to 1/2, and so 1/2 is certainly less than or equal to 1. So this p-series will diverge. So we have p-series, p equal to 1/2, that's less than or equal to 1, so this diverges. Okay, so we have convergence on one endpoint, on the left endpoint. We have divergence on the right endpoint. Okay, so this is certainly open here. Good. So from the beginning, we had the radius was 1/2, and now we found that the interval of convergence is this half open interval. So it's -7 halves, and that point is included. And then it goes to -5 halves, and that point is not included. And this is our interval of convergence. All right. So that concludes problem 4 on the practice exam. So in the next video, we'll go to problem 5.